Hi and welcome to John's Maths Book. In this video, we'll be exploring another key concept in mathematics. If you find this tutorial helpful, then please show your support by subscribing, liking, and leaving a comment. Your positive engagement helps me create more content and allows me to bring you more valuable maths lessons. Without further ado, let's go over to the whiteboard. We saw in a previous video that we could solve first-order linear differential equations of the form dy by dx plus p of x multiplied by y equals q of x, where p of x and q of x are either constants or functions of x, using an integrating factor, such that the general solution of the differential equation is given by this formula, where e to the power of the integral of px dx multiplied by y is equal to the integral of e to the power of the integral of px dx multiplied by qx dx plus a constant of integration. In the general solution of this differential equation, the integrating factor is given by e to the power of the integral of px dx, and it is seen on both sides of the equation in this formula. For more information about integrating factors, check out this video for a full explanation, and I've included a link to it in the description of this video. And so, fully equipped with this information, let's see if we can solve this linear first-order differential equation using an integrating factor. So we have dy by dx plus 2y divided by x is equal to sine x divided by x squared. To solve this, let's first identify the functions p of x and q of x. In this example, p of x is 2 divided by x, as seen here, and the function q of x is sine x divided by x squared, as seen here. Our integrating factor is therefore e to the power of the integral of px dx. So we know that px is 2 divided by x, so our integrating factor is e to the power of the integral of 2 divided by x dx. If we now evaluate the integral of 2 divided by x dx, we get 2 multiplied by the natural log of the absolute value of x. And using the laws of logs, this simplifies to the natural log of the absolute value of x squared. Because x is squared, it can only ever be positive, so we can now remove the modulus and simplify this to the natural log of x squared. So now, returning to our integrating factor, we can replace the integral of 2 over x dx with the natural log of x squared. So we have e to the power of the natural log of x squared, which simplifies to x squared. And so in this example, our integrating factor is x squared. And now, using the general solution of our differential equation shown here, we can plug in the integrating factor. So we have y multiplied by the integrating factor of x squared is equal to the integral of the integrating factor, which is again x squared, multiplied by the function qx, which is sine x divided by x squared dx. And we can see in this case, the x squared in the denominator cancels with the x squared in the numerator to leave the integral of sine x dx. And so evaluating this integral gives y multiplied by x squared is equal to a constant of integration minus cos x. And dividing through by x squared gives us the general solution to this differential equation, which is y equals a constant of integration minus cos x, all divided by x squared.